Hi everyone, let's talk about functions. Well, if you have had an algebra class, and I know you have, then you've talked about functions before. This lesson is going to be a review of algebra. More specifically, we're going to talk about functions, domain, range, zeros, maximum, minimums, increasing and decreasing. A function is a relation from a set of inputs to a set of possible outputs, where each input is related to exactly one output. So if we plug in numbers for x, those would be our inputs, and then these inputs are being sent to these outputs, and so this is the set of outputs. Well, the domain is the set of inputs, and the range is the set of outputs. Okay, so one common question arises in mathematics. How do we find the domain of a function? The easy answer is that the domain is everything that doesn't make the function undefined. So what makes a function undefined? In other words, what restrictions must we have on our domain? Well, there's going to be four restrictions, actually two restrictions that we're going to worry about. The first restriction is whatever makes the denominator equal to 0. So if we have a function where there's a fraction, we got to make sure that the denominator can't equal 0. Okay, the second restriction that we're going to have is with a even radical, like a square root or a fourth root or a sixth root or whatever. We can't have an even root of a negative number. Like the square root of -4, that's not a rational number. So we're not going to deal with those. The third restriction is if we have a logarithm, we know we can't take the log of 0 or a negative number, so we have to throw those out. And in this class, we don't really deal with logarithms, so we don't have to worry about that. The fourth restriction that we have is with trig functions. So we know that, for example, tangent of x, we know we can't plug in the tangent of 90 degrees. Or negative 90 degrees. It makes the tangent, the function, undefined. So we're really not going to worry about these two restrictions because we're really not going to run into them in this class. But these two we are. So we got to make sure our denominator is not equal to 0, and we need to make sure that whatever we're taking an even root of is positive. Okay, so let's look at some examples. So the first one, it says find the domain of f of x is equal to the square root of -5x minus 3. Well, we have an even root, and so we know whatever we're taking the even root of, in this case, is -5x minus 3. So we know -5x minus 3 can't be negative. It needs to be greater than or equal to 0. And so we just solve this. So add 5x to both sides, divide both sides by 5, and we would get x is greater than or equal to -3/5. And so our domain, we would start at -3/5 and go to the left. It would get smaller and smaller. And so the domain would be -infinity all the way up to -3/5, and we would include -3/5. So the square bracket, if you remember, that means that we include that point. But a parenthesis means that we do not include the point. So we can never equal -infinity. So we always have a parenthesis at -infinity and also positive infinity. Oh, in order to type the infinity symbol in MyOpenMath, you can type 2 zeros, as in the 2 middle letters in the word look. The other way is to click the drop down menu, the little down arrow, and choose the infinity symbol in there. Okay, let's take a look at problem 2. Problem 2 says find the domain of f of x is equal to x plus 8 over x minus 4. Since we cannot divide by 0, then x minus 4 cannot equal 0. So x minus 4 is not equal to 0. So solve for x by adding 4 to both sides. So x can't be equal to 4. So we write the domain as negative infinity to 4, but not equaling 4, union the set of 4 to infinity, but not equaling 4. So this is all real numbers except we hop over 4. Let's stop this video here. When you're ready, go on to the next video.